substitution first. We teach you the hard thing first. Honestly, we use it more. It comes up more often. Usually it's just the easier thing to do. But today we're going to learn the elimination method, and it turns out you're going to find this so easy. You're going to be like, why do we have to learn substitution? And I'm going to say to you, well, if you hadn't learned substitution, you wouldn't be thinking this was easy. All right, but it is. It's a nice, easy method. So again, we are solving systems of equations, and I just want to remind you, we have equations that are lines, and sometimes those lines intersect, and we get one solution where they cross. We get an answer for x and y where they intersect, where the two lines intersect. What else can happen with our pair of lines? Do they always intersect? No, they don't. Sometimes they are parallel, sure. And if we get parallel lines, what happens? What's the answer? No answer. There is none. Yeah, there's no solution because of those parallel lines. And then we could have a line and an identical line graphed right on top. What happens then? Infinite solutions, because they happen to be the same exact line. So they have a ton of points in common all the way down. So infinite solutions. And so this is always, every day, I just want to remind you, we're going back to just keeping that visual in your head of what we're actually doing, okay? We're graphing lines, but sometimes graphing is terrible. Most times graphing is terrible. And so we have some other methods, but the same things can still happen. So today we're learning the elimination method. And this method is used, a method. It is a method to solve systems by eliminating. A method to solve systems by eliminating one of the variables. Every time I teach elimination, I get in touch with my Arnold Schwarzenegger. It's like Terminator, okay. So we're going to be eliminating some variables. All right, and in order to do that, we have a couple of steps, and it turns out to be pretty easy steps, and most teachers teach this differently, but this is how I like to do it. I think it makes the most sense. Notice. Okay. The first step is we want to be sure that every term is stacked perfectly. All right? Stacked perfectly, meaning I want everything nicely lined up. I want my X things on top of each other, I want my Y things on top of each other, and I want my numbers on top of each other with the equal sign stacked as well. Everything needs to be perfectly lined up, perfectly stacked, okay? So that's the first step. Make sure everything is perfectly stacked. And then we need to multiply by 1 or negative 1. Today, we're multiplying by 1 or negative 1 to get an opposite variable. So what does that mean? To get an opposite variable, what we want to see is like a positive 7x, and what's its opposite? What's the opposite of positive 7x? Negative 7x, yeah. So that's what we want to see. we want to see opposites, positive 7x and negative 7x. Or maybe we want to see positive 9y and negative 9y. So we want to see opposites, okay? And then the third step is to combine equations and solve. Combine and then solve. You'll see when we get those opposites, what happens if I add a 7x and a negative 7x? What happens to that? It's 0. So we just eliminated one of our variables, okay? And that's the goal. So when we have opposites, we combine our equations. It's very cool. And one of them is gone. And then we can solve for the remaining letter. So whatever letter is left, we can solve for. And then our fourth step is to substitute into original equation. And solve again. Substitute. You're going to get a number answer on step 3. You're going to get like y equals 7. And then we're going to take that number and plug it back into one of our original equations and then again solve again. All right, so it's going to be pretty easy. I'm going to put the last step on here is check your answers. Always a good idea to check your answers. Plug your x and y in to your equations and make sure they balance. So that goes pretty nicely. Let's go ahead and see. I'm going to have you cross out your first 2 equations here because I didn't like them. And this is more of what you're going to see in Delta Math today. So here I have a lovely system of equations. This is a curly bracket. It just says that, hey, here's a whole grouping of equations, okay? We have 2x plus 4y equals negative 16. And then my second equation, I have negative 2x plus 2y equals negative 2. All right, so it says, step number 1, be sure that every term is stacked perfectly. Are our x's stacked up nicely? Are the y's stacked up nicely? Yeah? Are the equal signs perfectly stacked? Yeah, and then we got our constants over here. Are they perfectly stacked? Okay. So then we want to multiply by 1 or negative 1 to get an opposite variable. Opposite variable. So do we have some opposites on the board already? Yeah, we do. Already, we have a couple of opposites right here. We have positive 2x and negative 2x. Which means I really don't need to multiply by anything because they're already opposites. Okay, I could multiply by 1, but I don't need to worry about that. So what we can do is now, since I have opposites already, I'm going to simply combine the equations. Well, to combine the equations, I'm going to draw a line, and I get to total things up. What is positive 2x and a negative 2x? 0. Hey, look at that. They disappear. They cross out because of 0. 0 x's is nothing, all right? And then, here we're going to combine, what's 4 y's and 2 y's? 6 y's. Look at that, we're just adding things up. Then I have a lovely equal sign, bring down your equal sign. And then I have a negative 16 and a negative 2. How many negatives is that? Negative 18. Look at that. All right. 6y equals negative 18. Can I solve for y? Yeah, how do we get y by itself? Divide by 6. How easy is this? Pretty easy. So y equals, what's negative 18 divided by 6? Negative 3. Hey, are we done? Not quite, okay? We have one answer, but remember, our goal is always we need an ordered pair. All right, so we have an answer for y. So now I have to take my answer and substitute it into an original equation and solve. It does not matter which equation we choose. Would you like to substitute into the top equation or substitute into the bottom equation? You want to do the bottom? I would want to do the top. Why did I choose the top? Positives. Yeah, all right. So I'm going to take my top equation, 2x plus 4y equals negative 16. You'll notice I'm plugging it into an original equation. Can I plug it here into 6y equals negative 18? No, I can't plug it into that. That's not going to help me. Okay, so we got to go back to the original. And now I'm going to take my y value of negative 3, and where do I plug it in? To the y, absolutely, because it says I am a y. So we have 2x plus 4 times the negative 3 equals negative 16. And I get to multiply here. What is 4 times negative 3? Negative 12. So we have a negative 12. I have my 2x, and I have my negative 16. So 2x minus 12 equals negative 16. Can we solve for x now? Yeah, what should we do to solve? Add 12 to both sides. And so I have a 2x equals, who wins here, positives or negatives? Negatives by 4, good. And then how do we get x by itself? Divide by 2, divide by 2, very good. So we get x equals negative 2. All right, we have an x value, we have a y value. What's our ordered pair? Negative 2, negative 3, beautiful. I want to show you, you guys don't have calculators handy, but I'm going to grab my calculator and just show you how you can check, what you can do on your Delta Math calculators, since my calculators are still missing. So what we do is we go to the original equation, and again, we're just substituting the x goes, we're plugging in a negative 2 for the x, and we're plugging in negative 3 where we see a y. So we're going to do 2, plug in a negative 2, and then plus 4, plug in a negative 3, and then what should it equal? That whole left side should be equal to negative 16. So I'm going to hit enter, and is it equal to negative 16? Yeah. Yep. Okay, so the top equation works, it balanced. On the bottom, I'm going to plug in as well, negative 2, plugging in a negative 2 for the x, plus 2, I'm plugging in a negative 3 for the y. And what should it equal? It should get a negative 2. Hey, they balanced. Those equations worked out when I plugged in my numbers. All right, so all I'm doing is substituting in the numbers and making sure it works. Okay, so really easy to check. Let's try another. Number 2 here. I have, go ahead and write this down so you have it too, cross out what they gave you. We have the system negative x, maybe that's a negative 1x, plus 3y equals 6. And my second equation is negative 10x minus 3y equals 27. All right, ladies and gentlemen, first things first, is everything stacked up perfectly? All right, we got x's are nicely lined up, y's are nicely lined up, equal signs are nicely lined up, and then our constants are nicely lined up. Do we have opposites? We have a pair of opposites right here, positive 3y and negative 3y. So we're good. We can go ahead and total up our equations here. What is a negative 1x and a negative 10x? Negative 11x. And what happens with positive 3y and negative 3y? Yeah, it's 0y, so it goes away. Then I have my equal sign, and I can combine 6 and 27 to get 33. All right, now we can divide by negative 11 to get x all by itself. And 33 divided by negative 11 is? Negative 3. All right, are we done? No. What are we going to do? Figure out the y. We've got to plug it back in. Do you want to plug it into the top or the bottom equation? Top. All right, I like the top. So we have negative 1x plus 3y equals 6. And what am I going to do? Where does this negative 3 go? In the x position. It's going in place of the x. So we got to plug her in and then solve. So negative 1 plugging in the negative 3 plus 3y equals 6. Negative 1 times negative 3 is just a 3, positive 3, plus 3y equals 6. And then how do we get y by itself? Subtract the 3. So I get 3y equals 6 minus 3 is 3. And then divide by 3, divide by 3. So we get y equals 1. Excellent. All right, what's my ordered pair? Negative 3, comma 1. All right, what do you think of this? Pretty good, right? Pretty good. So we might have one more step to do because these already had opposites. All right. So we need to turn the page, and we're going to try a couple more. Let's look at number 6. Number 6. Is everything nicely stacked up? Yeah. Yes, good. We've got x's, y's, equals, and then constants. We're good to go. Do we have opposites? Yeah. No, we don't. We have positive 7x and positive 7x. If we were to combine those, what would we get? 14x's. It's not a 0. Okay, so that doesn't work. So what we have to do here is we're going to take one of the equations, and I'm going to pick one equation, and I'm going to multiply it by negative 1. And I'm going to rewrite my equations. I got a big arrow here because I'm going to rewrite them. Here's the biggest mistake people make. When we multiply by negative 1, we have to multiply every single term. So you have to share that negative 1 everywhere. So be very, very careful. Am I doing anything to my top equation? No. So I'm just going to rewrite that. 7x minus 4y equals negative 11. And then my bottom equation I have to multiply through by that negative 1. What's negative 1 times 7x? Negative 7x. Negative 1 times negative 10y. Positive 10y. Good. Equals, and then the thing most people forget, negative 1 times the 25. Negative 25. All right, now do we have opposites? Yes, we do. And that's the goal, to have opposites. And if we have opposites, now we can combine. What's 7x and a negative 7x? 0 goes away. What's negative 4y's plus 10y's? 6y, good, equals, and now we got a whole lot of negatives here. How many negatives do we have? Negative 36, beautiful. So how do we get y by itself? Divide by 6, beautiful. So we get y equals negative 6, excellent. Are we done? No. What should we do? Plug it back in, and we get to plug it into an original equation. So I'm going to go back to one of them over here, one of the originals. Do you want to plug it into the top or the bottom? Top? Sure. I would choose the top. I'd choose the top because the numbers look smaller. So I'm going to write my top original equation, 7x minus 4y equals negative 11. And I am plugging in negative 6. Where does negative 6 go? In place of the y. Very good. All right. So we have 7x minus 4, plugging in the negative 6, equals negative 11. 7x, what's negative 4 times negative 6? Positive 24, equals negative 11. And how do we get x by itself? Minus 24, minus 24. So you get 7x equals, that's a whole lot of negatives. How many negatives is that? Negative 35, good. And then we can divide by 7. So we get x equals negative 5. Excellent. So what's our ordered pair? Negative 5, negative 6. Great. Are we done? Let's just do one more here. Let's do number 7. Number 7, is everything stacked up good? Yeah? All right. X's, Y's equals numbers. Good. Do we have opposites? No, we do not. We have negative 2y and a negative 2y. Those are not opposites. So what do we need to do? Make them opposites by times in by negative 1. Multiplying through by a negative. All right. So I can do either equation. I'm just going to do the bottom equation so I can draw my little arrows that we've got to share that negative 1 everywhere. Am I doing anything to the top equation? No. So that's, I'm just going to rewrite 4x minus 2y equals negative 30. And on the bottom, what is negative 1 times negative x? Positive 1x. Good. Negative 1 times negative 2y? Positive 2y. Negative 1 times 5? Negative 5. So make sure you're changing all the signs. Now, do we have opposites? Yes. Here we have our opposites, positive 2y and negative 2y. Now we can combine our equations. 4x's plus 1x is 5x. Negative 2y and positive 2y? 0. Equals, we have a whole lot of negatives. How many negatives do we have? Negative 35. Good. And then we should divide by 5, and x equals negative 7. Good. Negative 7. Great, great, great. And then the last step is to substitute. Which equation do you want to substitute into? The top. I like the top just because it seems like there's less negatives, but I don't. You could pick either equation. So I'm going to use the top equation. And where are we plugging in this negative 7? It goes in place of the x, because it says I am an x. So we have 4 plugging in a negative 7 minus 2y equals negative 30. What is 4 times negative 7? Negative 28 plus 2y equals negative 30. And how do we solve for y?
How to change from negative to positive?
That's a great question. Thank you. Thank you, Noah. I'm going to give you a sticker because you found my mistake. Ooh. Pick a sticker.
Good boy, Noah.
All right. Okay. Copy errors cause us all kinds of grief in systems of equations. All right. Thank you, sir. What should we do to solve for y now?
Good job, Noah. Plus 28.
Add 28. Very good. Add 28 to both sides. All right. So the negative 28 and positive 28 cancel out. We're left with a negative 2y equals. Who wins? Positives or negatives? Negatives by 2. Very good. And we need to divide by negative 2. Divide by negative 2. So we get y equals positive 1. Very good. All right. We have our ordered pair. Negative 7, comma 1 for our solution. Give me a, how are you feeling? Are you feeling good? Thumbs up? Let's do thumbs or fingers for. Okay, good. All right, pretty easy. Very good, ladies and gentlemen. You have a delta mass